We're often asked about the resolution of our microscopes. The answer, of course, depends on magnification of the objective lens and its projection of the image onto the camera sensor. More camera pixels generally equals more resolution. The numerical aperture, or NA, is a measurement of the light gathering performance of the lens. Photographers may be familiar with the description of a fast lens, meaning it can gather light quickly without a long exposure. Theoretically, one can have high resolution with low magnification, but at the cost of a large and expensive objective lens. You will notice that taller objective lenses have higher NAs. They get closer to the sample to collect more light. The ultimate resolution of wide-field microscopy is the diffraction limit. This is based on the wavelength of light used to produce the image. The diffraction limit is approximated as the wavelength divided by 2. So for a typical green wavelength of 500 nanometers, which is the center of our visible spectrum, the diffraction limit is approximately 250 nanometers, or a quarter of a micron. As a result, we would like to project a 250 nanometer square area of sample onto at least one pixel of our sensor, preferably 2. This table shows the sample dimension per camera pixel for a variety of objectives. As you can see, at 40x, we are projecting a square of sample area with 216 nanometer sides onto each camera pixel. Using a higher magnification objective lens only leads to oversampling of the diffraction limit, although the increased NA of the higher magnification objectives will contribute towards achieving the actual diffraction limit. In this image, taken at 60x, we can see that each pixel samples around 150 nanometers, as shown in the table. It's important to recognize that any object smaller than the diffraction limit will appear as large as the diffraction limit in an image. So the answer to the question, what is our resolution, is that it is the diffraction limit, or around 250 nanometers, or a quarter of a micron, at 40x and above. And as I've mentioned before, the role of the microscope is to preserve the resolution provided by the objective lens. And so as long as the objective lens has sufficient NA, this will be true. I hope this has been helpful, and thank you.